Hi everyone. So my STEM lesson plan is based off of a DIY, do-it-yourself AC unit that my chemistry students are actually currently doing. This is a lesson I'm actually currently doing in class right now. So it's inspired off of this unit. I made this summer because I was very hot during the heat wave. I saw a problem and I wanted to fix it. So I got a bucket from Home Depot. I drilled some holes in it. I added my PVC piping and a Tupperware container with some water. I froze to make ice to fit, and then I added my fan on top. So this cooled me down during the summer, and I thought it would be a cool inspiration for a maker project for my chemistry kids. So what I created was this DIY AC project where the students are making a portable cooling device. So the idea is that they're going to scale this down to be a desktop version that they could carry from class to class. They're making prototypes and then they're going to create a sales pitch, and we're going to have a Shark Tank type presentation where I invest points, extra credit for the kids who win, and it's scaled down based on the rubric if they meet all of the requirements of the lesson. So the idea is that the first thing that we did was they had to do some research. So they had to go online and research other two articles and find different heating and cooling systems to get the basics. And I also use this as just a baseline to see where their research skills are. And now looking at those, I can scaffold and make sure that I create lessons moving forward, including all the digital citizenship pieces I want to add, and search techniques. So I can see where they are and where I need to bring them to based on this assignment. So this research was very, very basic. And then are creating a design. If you notice the dates, we're doing this right now. So on Friday we made the design, and then on Monday they're going to build their prototypes. So this full week is going to be about analysis of those prototypes. So here's the rubric I created. They all have this so that they can figure out exactly how they're going to be graded. This week, what they're also working on is these spec sheets. So each one of these has some guided questions that brings students to all of the key points for my unit and my learning standards. So in this one, they're going to devise an experiment to test how long their AC unit will last, and that has to go on their poster. So in the end, they're going to create a prototype of their small scaled version and as well an ad poster. So the ad poster must include part of their design, how they pick their design. So they'll run that experiment this week. They're also going to quantify heat transfer. Here's where the big math piece comes in, is that they're going to calculate the amount of heat the unit will absorb. Q equals MC delta T is one of the main equations they need to know for chemistry. So they're going to be using those heat equations that are part of the curriculum just applied to their unit for reinforcement. So we've done a few labs and we've done some concepts in class, and now this will culminate into this project. They're going to do qualitative heat transfer, so this has a lot to do with the language that they need to understand. And so all of these specs must be on their final poster as well as in their final presentation. So this is a way to differentiate, because every group will create a different project. They'll have a different mass. Their project will have different needs than other projects, but it's clearly laid out so all the groups are getting the same instructional goals of knowing that they understand how phase changes work. They're going to draw particle diagrams. All of these pieces have to be the same for all of them. The same standards are hit, just in totally different ways. And then efficiency is a big one. One of the new goals is to talk about energy transfer from one type of energy to another. So I'm trying to make sure that I hit that here, where students understand that electrical energy turns into mechanical energy in the fan, and all the other pieces of their DIY AC unit. So a few things about this that I love is the kids are making something. So they have a prototype, they get that success. They're collaborating, they're working in groups of four where they had to agree on a design, they're going to build together. They're going to build and then design an experiment, test and modify. And so I really love those ideas and bringing those all those STEM pieces together. Now, in terms of engineering, they have to figure out scaling. So they're going to have to think about the cost of materials as well as the efficiency of their machine. And then in terms of technology, my students actually do all of this collaboratively through my Google Classroom. So they're hitting a lot of those other 21st century skills. So just wanted to pull up, here's my learning standards that I'm working off of. So I'm hitting all of these learning standards in throughout the project. And since they're doing a lot of calculations, there's a lot of science and a lot of math, a lot of English language in terms of their communication skills, as well as their presentation skills. So it all comes together that way. And also, I just wanted to mention that collaboration, communication, creativity, and critical thinking are these new 21st century skills I'm working to incorporate with my high school kids. And so they're working together and they have to communicate. But really, the creativity piece I love because some of the groups, especially kids that I didn't expect, were really having very unique ideas. And just getting their really literally hands dirty and being able to build something is rare for them in high school. So that's a really nice little piece of it that I like to bring in. Um, and it's easier for me to scaffold in this way when I show them something, they explore it, then they do some more research, then they are doing the testing and experimenting, and then I ask them to elaborate, and then I ask them to evaluate. So they're evaluating as well, which is a much higher level. In terms of bringing this to a younger group, you could totally scale this back, make it less calculation based, more exploring based, have them see different types of phase changes. An interesting piece is that many students do not understand where condensation comes from, that the water moisture is already in the air, the vapor, it's water vapor turning into liquid water. So to explicitly find out that from them in that first, when I first show them my build, that's really helpful. And so just to wrap it all up, in the end, what my students are going to do is they're going to have a pitch and they'll hand me a portfolio. And so their portfolio will be written up chronicling their entire experience, including their build, pictures, and all of their spec sheets. So I hope you enjoy my lesson, and that's it on heat and energy.